Welcome back, and this is part one of my videos on indefinite integrals. So an indefinite integral is when you integrate an expression or a function that doesn't have any limits on the integral sign. The result of that is that you'll have a plus c. Now I'll cover that in a little bit more detail in just a moment, but I'll go through three rules, and all these problems on the right here, they all involve one of those three rules. I'll finish with a little problem whereby we have been given a derivative of a function and we need to find the original function given some information. Okay, let's dive in. Just before we start, let's just get this absolutely clear for everyone that if you start off with a function and you differentiate it, you get f prime or dy by dx. If you differentiate it again, you get f double prime or d2y by dx squared. That is a measure of concavity. If we integrate those expressions, then we will move back the other way, resulting in the original function that we had. So that is known as the antiderivative or antidifferentiation in some courses. Okay, on to our first questions then. So here on the left, it says integrate a numerical value, just 3. Well, that will be rule 1. If we integrate just a constant value, we would get constant x plus c. So the result for this would just be the integral of 3 would just become 3x plus c. And that is the answer to that part A. Here, we are going to be using rule 2, whereby if we have an integral of a value and x has a power on top of it, we will add 1 to that power and divide by that new power. So here we go. We're going to integrate this. We will get 5x to the 5 divided by 5. Now those 5s would cancel, okay, leaving just x to the 5. But don't forget about your plus c. That is very important on an indefinite integral. Like I said above, there may be a constant that disappeared when we differentiated it. So here, we're just got another problem here where we're going to leave the 2/3 exactly the same for right now. Then we have x to the 3rd, so add 1 to that. So add 3 over 3, that becomes 4 over 3. Now, when we divide by 4 over 3, you can just multiply by 3 over 4. And when you do that, what would happen is these two parts here would cancel out, and the 2 over 4 can cancel down to a half. So this would result in a half, then x to the power 4 over 3 plus c, and that is the answer to part C.
Alrighty then.
Okay, so let's have a look at 3 more problems, D, E, and F. Right, we have an expression here, 3x plus 7 raised to the power of 4. Now, we don't want to expand that bracket, but we want to use one of our rules. So let's go down here and have a look at rule 3, where it says if we have a bracket and also parentheses raised to a power, we can add 1 to that power, divide by the new power, and also divide by the derivative of the bracket. Okay, that's very important, then plus c. So let's go ahead and just see that in action up here. So we are going to add 1 to the power. So first of all, this thing in the parentheses, the brackets here, stays exactly the same. That is also important. But we add 1 to the power, divide by the new power, but then divide by the derivative of the bracket. Now, the derivative of the bracket will just be 3. So I like to times that through by 1 over 3. It's really a reverse chain rule problem. Then don't forget your plus c. So your final total, or your final result here, should I say, would be 3x plus 7, all raised to the power of 5, over 15 plus c. E, but before I do that, I'm going to just rewrite the problem slightly. I'm going to bring the 2x minus 3 up to the numerator, but then put a minus 2 here. I'm going to use the same rule as we just did, number 3, remember? Add 1 to the power, divide by the new power, divide by the derivative of the bracket. So therefore, we will get, okay, so at the moment, I just leave things the same, right? So everything inside this parentheses here just stays the same. So add 1 to the power, that makes that minus 1, not minus 3. And then we divide by minus 1, but then we also divide by the derivative of this, right? And derivative of that is 2. So like I did on the former question, I'll just times through by a half. We will get a plus c in the next line down, but that means then we will get a negative. Now 4 divided by 2 is 2, open brackets, 2x minus 1 to the minus 1. Now, it depends what course you're doing. You may have to leave it like that, or you may need to leave it as a fraction. Don't forget, we got that plus c. If I needed to leave it as a fraction, it's negative 2 over 2x minus 1. okay, plus c, using laws of indices there. Final question. Sorry, we'll just squeeze it in here at the end here. Right, so first of all, remember anything to the power of a half is the square root. So therefore, we're going to go the opposite way. We're going to change the square root into 5x plus 1 to the power of a half dx. So we're integrating with respect to x here. Now we're going to add 1 to the power, divide by the new power. So first of all, this becomes 2x, because remember rule 1 was constants become that constant followed by x. And then now we have to add, okay, so remember, things stay in the brackets, they stay the same. Add 1 to the power, becomes 3 over 2. Divide by the new power, so that's the same as timesing by 2 over 3. And divide by the derivative of the bracket, which is 5, right? So quite a few things happening there. And then we will have our plus c, but we need to tidy that up. We can't leave it like that. So let's just have 2x plus, now that will be 2 over 15, right? This thing stays the same in the brackets to the 3 over 2 plus c. Now, I think that's good enough to leave it like that. Unless you were told in the question to leave it any other form, I think we've done. Okay, we've got our last two parts here. So a little bit similar to the other ones, but we're just going to use a combination of these three rules. So let's have a look at G. Right, first of all, we're going to rewrite that using our laws of indices as 2x plus 1 all raised to the power of 1/3 dx. We've got the feel for this now. We're just going to add 1 to the power, divide by the new power. So this will become 4 over 3. Dividing by the new power, so that's dividing by 4 over 3 is the same as timesing through by 3 over 4. But we must also remember to divide by the derivative of the bracket, and that is 2. Okay, and we'll get our plus c on the next line. So our final answer will be 4, 8, 12. 12 over 4 is 3. So 3 on the numerator, 2 on the denominator. We've got our 2x plus 1 to the 4 over 3. Now, I won't go into the laws of indices to unpack that because we don't need to, but we must remember our plus c. Okay, last one. H looks complicated, but we just got to tidy it up and put it in the index form to begin with. So we've got 3, and then we've got 2x plus 1 raised to the power of negative half minus 2x. Yep, we've got to integrate that with respect to dx. Right, adding 1 to the power will become half. Dividing by a half is the same as timesing through by 2 over 1, and then dividing by the derivative of the bracket, which is just 2. So therefore, we have our term at the end here where we have to integrate, so that become 2x squared over 2. Those 2's will cancel, and then we have our plus c. So let's just tidy this whole thing up now. We're going to get 6, so this will be 6 over 2 is 3. Then we get 2x plus 1 raised to the half, and those 2's cancel, leaving us minus x squared plus c. Okay, so on the final part of the video, I just thought it would be interesting to actually find one of those values of c that we've been talking about. So here we're told that we need to find a function, but we've been told the second derivative and the first derivative and some values of x and y. So let's just start this problem off. If we integrate the second derivative function, okay, with respect to x, we will end up with the first derivative function, okay? So that means then if we are integrating 2x plus 1 with respect to x, we will get 2x squared over 2 plus x plus c, right? And that would be derivative function. So let's just move that over to the side there, and let's just put down f prime of x, right? And therefore, these 2's will cancel, just leaving us with f prime of x is equal to x squared plus x plus c. Now, in this part of the question, they did tell us some details. They said that given when x is 1, y is equal to 3. So when we plug 1 into the derivative function, the output was 3. So that's a very important bit of information, because when we plug 1 into this, therefore then f prime of 1 would equal 1 squared, which is 1 plus c. But remember, they just told us that this here was equal to 3, because that is the derivative. So 2 plus c, Therefore, we can deduce that c is equal to 1. Right, so once we know that c is equal to 1, we have actually got the entire derivative function. Right, we don't need to have the c in it. So what we'll do is I will rewrite that over here in orange, that the original derivative function, is x squared plus x plus 1 now. And they also say that when we plug 2 into the original function, we would get 7. So what we'll do is we'll integrate the derivative function, right? Okay, so therefore integrating this, we would get f of x, and we would get x cubed over 3 plus x squared over 2 plus x plus c. Okay, now the c is not the same as the other c. It was just a placeholder because we didn't know what that constant may be, but we can definitely use this information above to help us find it. So remember it said that when x is 2, y would come out to be 7. So when x is 2, we will get 8. Leaving us with 1 over 3 equals c. And there you go. So that was the original c. So if we just take that c now, and let's use this color here, we're going to take that, we're going to plug it in to this original function there. That would give us our very final result. The original function was f of x is equal to x cubed over 3 plus x squared over 2 plus x plus 1/3. Thanks for watching. Be sure to check out part 2 where I go through the integral of an exponent function. Also part 3 where I do the integral of a natural log. I'll see you next time.